Hi everyone, this is Kalpana from Department of Chemical Engineering, Hindustan College of Engineering and Technology. Today we are going to discuss few problems in chemical process calculations. It is within the calculation of material balance with and without chemical reactions. So here we will discuss about the material balance problem involving both chemical reaction and without chemical reaction. So before that we have to be clear about the stoichiometric principles. Stoichiometry is the theory of the proportions in which chemical species combine with one another. The stoichiometric equation of a chemical reaction is the statement of the relative number of molecules or moles of reactants and products that participate in the reaction. For example, nitrogen plus 3 molecules of hydrogen will combine to form 2 molecules of ammonia, which is NH3. Next, we'll see about the material balance. What is material balance? Material balance expresses the constraint of conservation of mass as applied to a process. Then, batch process. We have three main types of processes. One is batch process. In a batch process, raw materials are fed into the process at the outset. The process then runs for more length of time producing product, but no product is removed and no additional raw materials are input, but energy may be input or it may be withdrawn during the product, but no input will be given as a material during the batch process. At the end, the product will be removed. So once when the process is completed, the product will be removed. The bottom line is that no mass enters or leaves while the process is running. Then continuous process. In this type of process, raw materials continuously enter and the product continuously leaves the process. So here it is completely opposite to that of the batch process where we feed the raw material continuously and will withdraw the products continuously during the entire process. Then it is semi-batch process. A semi-batch process does not fall fully under either batch or continuous classification. It is the combination of both batch process and continuous process. Here we can say water purifier as an example for semi-batch process, where we have the resin. It is a stable one which comes under batch process and will feed the unpurified water, that is dirty water, into the resin and we will get the pure water. So it is combination of both batch process as well as the continuous process. Then it is about material balance equation, because without material balance we will not be able to solve all those problems. So here we have given the general material balance equation. So input plus generation minus output minus consumption will be equal to the amount of product which is accumulated inside the reactor. So input is nothing but it enters through the system boundaries, and generation, it is produced within the system. Output, it exits through the system boundaries, and consumption is used up within the system, and accumulation is built up within the system. So accumulation is the thing which is left over without any reaction, without undergoing any reaction. Next, let us solve a few problems involving and without involving chemical reaction. Here first problem is about sulfur dioxide is produced by the reaction between copper and sulfuric acid. How much copper must be used to get 10 kilogram of SO2? So we have to determine the amount of copper which is used to get 10 kilogram of SO2. Here the equation is also given. Copper plus 2 times of sulfuric acid gives SO2 plus 2 times of water. So as per the above stoichiometry, 1 mole of copper reacts with 2 moles of sulfuric acid to produce 1 mole of sulfur dioxide. We know moles is equal to mass of the chemical divided by molecular weight of that particular chemical. Hence, mass of the chemical is equal to moles into molecular weight. So mass of 1 mole of copper is 1 into 63.54, which is the atomic weight of the copper. So we will get the answer as 63.54 kilogram. As in the question they have given the data in kilogram, we have to determine this in kilogram. Then mass of 1 mole of sulfur dioxide is 1 into 64, which is equal to 64 kg. That is 63.54 gram of copper produces 64 gram of sulfur dioxide. So to produce 10 gram of sulfur dioxide, it is calculated as 64 by 63.54, which is equal to 9.93 kilogram. The next problem is about what is the weight of iron and water which is required for the production of 10 kilogram of 100 kilogram of hydrogen. So 3 times of iron reacts with 4 molecules of water to produce Fe3O4 plus 4 hydrogen molecules. Here they have given the stoichiometries also. So as per the stoichiometry, 167.52 kilogram of iron produces 8 kilogram of hydrogen. For 100 kilogram of hydrogen, iron required is equal to 167.52 divided by 8 into 100, which is 2094 kilogram. Similarly, 72 kilogram of water is needed to produce 8 kilogram of hydrogen. Therefore, for 100 kilogram of hydrogen, water required will be equal to 72 divided by 8 into 100, where we are getting 900 kilogram as the answer. So we have determined the amount of iron and water required to produce hydrogen respectively. The next one is about the humidity. So here in the question they have given the dry bulb temperature and the dew point of the ambient air were found to be 303 Kelvin and 298 Kelvin respectively. We have to calculate the absolute molecular humidity, the absolute humidity and the humidity at the saturation. So these three are the unknown compounds which is to be determined. And the data is also given. Partial pressure of the water at 303 Kelvin is 3.132 kilopascal. Vapor pressure of the water at 303 Kelvin is 4.243 kilopascal, and barometric pressure is 101 kilopascal. So in this solution, absolute molecular humidity is partial pressure divided by total pressure minus partial pressure. So this is the formula. Here we are substituting the partial pressure of the water which is given divided by barometric pressure is nothing but the total pressure. So in substituting all the values and calculating, we have obtained 0.032 kilogram vapor per kilogram dry air. Next one is absolute humidity, which is equal to 1.6, which is absolute molar humidity, which is equal to 1.6 into 0.032, which is 0.0512 kilogram mole vapor per kilogram mole dry air. So from the molar humidity we can determine the absolute humidity. So multiplying the values will obtain the absolute humidity. Then humidity at the saturation Hs. So humidity at the saturation Hs is Ps divided by P minus Ps. So Ps is also given in the question, which is nothing but the vapor pressure of the water. On substituting the values, we have obtained 0.044 kilogram mole vapor per kilogram mole dry air. The next one, thank you. So hope you have got some few ideas about the material balance with and without chemical reaction problems. Thank you.